So in this video, we're going to talk about the idea of how to really differentiate about Sn1 versus Sn2 reaction. On an exam, you may be faced with a question and you may be wondering, is it Sn1 or Sn2, right? So let's look at the differences. So Sn1 reactions, we say a tertiary alkyl halide is better than a secondary alkyl halide. All right, so what I'm saying, and we're going to do an example. What I'm saying is that a tertiary directly tells you that really we're looking at an Sn1 reaction without the presence of a base. All right, and without the presence of a base, what I'm meaning is that with the presence of a base, we're really looking at elimination. But again, we're sticking to substitution reactions, Sn1 versus Sn2. We're saying that a tertiary alkyl halide is better than a primary alkyl halide. The nucleophile is actually weak in Sn1 reactions, so weak nucleophile, very important. Now the nucleophile can also be a solvent, right? So you have to keep that in mind. So your nucleophile in Sn1 reactions can also be your solvent. Now the solvent, speaking of the solvent must be, right, so let's use as bullet points. Solvent is usually what we call polar protic, right? So any solvent with OH or NH bonds. What I'm really saying is any solvents like your methanol or ethanol or even your ammonia, right? Polar protic solvents. And lastly, just for knowledge, we say the rate is equal to some equilibrium constant, or the rate constant K times that of the alkyl halide. For Sn2 reactions, oppositely, we say a methyl halide is actually better than a primary alkyl halide, which is better than a secondary alkyl halide. Now, really in organic chemistry, we really use the primary alkyl halide. Most reactions, you will see the primary alkyl halide. Now, converse this to Sn1, in which we now have a strong nucleophile. So when I think about strong nucleophile, I want you guys to think about charge, right? So usually when something is charged, it directly tells you the nucleophile is strong. So I want you to put that in your head, that it's the idea of something being charged. Now the solvent effects is opposite to that of an Sn1 reaction. The solvent effects is actually, or solvents that we use are actually polar aprotic. So these include your DMSO or your acetonitrile and various others. So polar aprotic solvent. And then lastly, for background information, we say the rate is equal to K times the alkyl halide times the nucleophile, or the concentration of the nucleophile. So with keeping these rules in mind, let's look at a few examples to kind of tell if we're dealing with an Sn1 reaction or an Sn2 reaction. If on an exam you're given this molecule, and you're given this reaction, would this be Sn1 or Sn2? Well, the first thing I'm going to do is look at the carbon that contains the alkyl halide. So I'm really looking at a primary alkyl halide. So that's number one. That's leading towards Sn2 reaction. And the nucleophile is strong. I see a charge, right? So I see a primary alkyl halide. So that means you think about the primary alkyl halide as the attack, as the window for attack is really open because hydrogens are so small and the nucleophile is charged. This is a quick concerted reaction. So I should expect an Sn2 reaction in this case. And my product, my major product, my major product being this molecule. So notice again, I look at my nucleophile, it is strong. I looked at the alkyl halide that I'm dealing with. I'm dealing with a primary alkyl halide, and that is wide open. So I'm looking at an Sn2 reaction. Now, if you looked at the other videos that I mentioned, there's a Sn2 reactions. You never do Sn1 reaction on a primary alkyl halide. Right? So never do Sn1 reactions on a primary alkyl halide. So that's kind of one of the rules. Let's look at this one. Is it Sn1 or Sn2? Now, before I continue, well, let's talk about it. You're given this reaction. Is this Sn1 or Sn2? Well, I'm looking at a secondary alkyl halide, so I want you to be careful. I'm looking at a secondary alkyl halide. Now, when the alkyl halide is secondary, things become a little bit in the gray area. Right? So it's not as straightforward as a primary or a tertiary, but when it becomes secondary, you have to look at other things. Now, if I look at the nucleophile, I could see out of these two, the OCH3 minus is going to be my nucleophile. It is stronger. Remember, we said that strong nucleophiles, we're looking at charges. So strong nucleophile, okay, well, now I'm leading a little bit to Sn2. The secondary alkyl halide, okay, it could really go both Sn1 or Sn2, but the strong nucleophile really kind of tells me that, okay, now we're probably looking at an Sn2. What about the solvent? The solvent should clarify everything. Right? Notice that we have OH bonds in the methanol. Right? So we have OH bonds in the methanol. So what does that tell you? Well, this again is a gray area. Remember we said that Sn2 reactions are the one that favor polar aprotic solvents, and Sn1 reactions favor polar protic solvents. So the solvent here is polar protic, so you would think it is Sn1, but because our nucleophile is so strong, we're really still looking at an Sn2 reaction. So this happens in all in one step, a concerted reaction. We kick off the bromine, and so we get the product as being this. Now I want you to notice something here, right? So we said that this was essentially Sn2. Notice the stereochemistry changed, right? So in Sn2 reaction, we did say that if you started with an R configuration, because we're actually with a chiral center here, then the configuration will be S in the product, or vice versa. If we started with S as the reactant, then the configuration of the product should be R. Right? So this is a classical Sn2 reaction. So this one was a little bit of gray area, but again, we looked at several different things before we made our decision. How about this one? Is this Sn1 or Sn2? Well, what kind of alkyl halide I'm looking at? I'm looking at a tertiary alkyl halide. There's no hydrogens on the carbon. Okay, so remember we said that for Sn2 reactions, you never do Sn2 reactions on a tertiary alkyl halide. So that immediately should signal that we're dealing with the Sn1 reaction. Now, what else can we look at to kind of to buffer our idea to support the Sn1 reaction? Well, the solvent, or in this case the nucleophile, remember in Sn1 reaction the solvent can also be the nucleophile, it is weak. There's no charge in the solvent. Right? So that is another clarification that we're looking at an Sn1 reaction. So if we run through the mechanism real quick, or in other words, the product, what we're really saying is that we should get this as the product. Now, Sn1 reactions, and that is the product, show no stereochemistry. So we really do not show any stereochemistry in Sn1 reactions, and I'm going to show you why. Now, if we look at the mechanism real quick, what we're really saying is that the bromine leaves and we create our carbocation. Now, once the bromine leaves, you should remember this from general chemistry. Look at the carbon. What is the geometry around the carbon? The carbon is now flat. The carbon is actually trigonoplanar. And so this is why Sn1 reactions, the product, showed no stereochemistry, even though the reactant in this case showed stereochemistry. Okay? So because the carbon now becomes flat, my water molecule can now attack the carbocation. Okay? And essentially, in this case, we have an oxygen that has two hydrogens. It still has a lone pair, so it has a positive charge, and we still have our methyl group. Another water molecule, because we have plenty of these in solution, is going to come in, act as a base, take off the hydrogen, put the lone pairs in the form, put the electrons in the form of lone pairs on the oxygen, and we get our desired major product as OH. There's our CH3. And obviously we get a little bit of acid, H3O plus, and our leaving group. Okay. So that would be an Sn1 reaction. How about this one? Professor gives you this on the exam. Is this an Sn1 or Sn2 reaction? Well, look, I'm on a secondary alkyl halide, which is right here, right? So remember we said that secondary alkyl halide, you have to look at more things because it's kind of a gray area. It can actually go both ways. But look at our nucleophile. Our nucleophile is really strong. We have positive charges, so we know that this is an Sn2 reaction, all in a concerted step. Now remember we said that Sn2 reactions show stereochemistry, and so essentially we should have the opposite effect happening, right? So nothing happens to the CH3, stays the same, but now the nucleophile is going to be on the opposite end. So it attacks from above because the chlorine is going down, so it is going to stay above, and that is a product. So ladies and gentlemen, these are classic examples of how to really differentiate between an Sn1 and an Sn2 reaction.